Today, students, we're going to be learning about the three trigonometric ratios reciprocals. Last lesson, we taught you about the sine ratio, the cosine ratio, and the tangent ratio of a right triangle, right? When we have a right triangle, we have a right angle. Across from the right angle is what we call the hypotenuse. We have two other angles, two acute angles, A, and this one's unlabeled, but it could be B. And the three trig functions that I introduced last time was the sine. Again, it's pronounced sine of A. So if I'm looking at A, the sine is the opposite side over the hypotenuse. The cosine of A, cosine is adjacent over the hypotenuse, and the tangent of A is the opposite over the adjacent. That's those three basic trig functions, which hopefully you remember from the last lesson. Today we're going to talk about the reciprocals. The reciprocals just means that that fraction is flipped upside down, or the reciprocal of the sine function, we call it the cosecant. And that's what's kind of weird. Cosecant starts out like cosine in a sense, but actually the cosecant is the reciprocal of the sine function. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. Now, when I say reciprocal, that just means that it's the fraction flipped upside down. So in other words, let's look at those six ratios again. Sine of A is opposite over hypotenuse, but the cosecant of A is the hypotenuse over the opposite. Look at those two fractions and notice how they're just flipped upside down. The cosine of A is the adjacent over the hypotenuse, where the secant is the hypotenuse over the adjacent. Again, it's just that ratio flipped upside down. It's the reciprocal. The tangent of A is the opposite over the adjacent, where the cotangent of A is the adjacent over the opposite. It's just flipped upside down. So let's do an example. If you need to slow down and rewind and listen to that again, please do so. But here's an example. We have this right triangle. The right angle is down here in the bottom right angle, so this 5 would be our hypotenuse. Since we're looking at angle A in all of these trig functions, the opposite would be the 3, and the adjacent would be the 4. Remember, the adjacent side always forms the angle we're looking at with respect to the hypotenuse. So the adjacent and the hypotenuse always make the angle that we're taking the sine or cosine of. So again, the sine is going to be the opposite over the hypotenuse, so the sine would just be 3 over 5. Where the cosecant is the reciprocal of that. It's the hypotenuse over the opposite. So all it is the reciprocal, or 5 over 3. Very simple. It's just flipped upside down. Cosine is the adjacent over the hypotenuse. So I come here and I do the adjacent side is 4. The hypotenuse is 5. The secant is just the reciprocal of that. It's the hypotenuse over the adjacent. So I take and I do the 5 over the 4. And again, look at that. If you just look, these two fractions are flipped upside down. The tangent of A is the opposite side over the adjacent. So that's going to be 3 over 4. And the cotangent is the reciprocal, or the adjacent, over the opposite. So we do 4 over 3. Now, when you get to your homework, again, you're going to get a lot of square roots that you need to rationalize the denominator. So let's do one that you'll see in your homework. For instance, we're missing a third side. I want all 6 trigonometric ratios. The first thing I'm going to do is I'm going to try to find this missing side. And what I'm going to do is, to make things easier, I'm going to use a separate sheet of paper, and I'm going to write down this triangle that I'm doing, and angle D is what we're looking at. So now what I'm going to do is I'm going to show you right here. You see that I've written that right triangle. Let's go back to the word. See, I got the 4, the 2 square roots of 7, angle D. and my 90-degree angles. So again, I got my 4, my 2 square roots of 7, my angle D, and my right angle. So now I'm going to use Pythagorean's theorem, a squared plus b squared equals c squared, in order to solve for this missing side. I'm going to label this side B because it's not the hypotenuse. Here's my right angle. This is the hypotenuse, which was always going to be C. So I'm going to do 4 squared plus b squared equals 2 square roots of 7 squared. 4 squared is 16. I don't know what b squared is yet. 2 squared is 4. The square root of 7 squared is just 7. So I get 16 plus b squared equals 4 times 7 is 28. Minus 16 from both sides. I get b squared equals 12, or b equals the square root of 12. Now the square root of 12, remember we need to reduce this. Square root of 12, 12 is 4 times 3. 4 times 3 is that 12. I can square root the 4 and get 2 square roots of 3. So I come back here, my missing side is 2 square roots of 3. Now again, if you need to rewind and rewatch me work through that, do so. Just be careful when you're squaring things that are square rooted. When you square the square root, it just becomes the 7. But when you square that whole number out in front, the 2, it does square and become 4. And I find out that missing side's 2 square roots of 3. So now I'm going to go back to here, and I'm going to write in, if this will let me, come on. I'm going to write in as best I can 2 square, ooh, that was cool, square roots of 3. Now I can actually solve for all these sine functions. Now be very careful again when we do this that you rationalize the denominator. So for instance, the sine of D. Now again, the first thing I'm going to do is I'm going to find my D. Here's my D. This is my D. If this is my D, or the angle I'm looking at, I'm going to first label the hypotenuse. The hypotenuse is across from the right angle. So this would be my hypotenuse. Across from my D over here, this would be considered my opposite now. And the third side that makes angle D with the hypotenuse is my adjacent. So this is my adjacent. That's a weird D, adjacent. All right, so now remember, sine is opposite over hypotenuse. It's opposite, which is 4, over the hypotenuse, which is 2 square roots of 7. But I need to rationalize that square root of 7. So again, what I'm going to do is try not to use that. I'm going to go back to my paper. My paper is so much nicer. So remember, we had 4 over 2 square roots of 7. 4 over 2 square roots of 7. I'm going to multiply the bottom by the square root of 7. I don't need to do the 2 because it's not square rooted, just the square root of 7, and the top by the square root of 7. I get 4 times the square root of 7 on top, and then I get on bottom 2 times 7, but notice the 2 goes into the 4. Rather than multiply the 2 and the 7 and get 28 and then reduce, I'm just going to say 2 goes into 4 twice, and I get 2 square roots of 7 over 7. So that would actually be my solution for this one right here. So what I'm going to do now is I'm going to actually go back here and get, I'm going to first of all undo that mess. And I'm going to, come on, yeah, there we go. Go into here and type it in this way because this will be so much neater. So I'm going to do my fraction, and I'm going to type in 2, and then I can type in my square root of 7 over 7. Now, what's really nice about that is I can actually, I'm trying to get these reciprocals back up there. The reciprocal here is just going to be, the cosecant is just going to be the reciprocal of the sine function. So again, all I'm going to do is get my fraction, and I'm going to type in 7 over, well, actually, I'm going to go back to, remember what it was here? Go back to here, because I rationalize the denominator. I want the reciprocal of this. Remember, I don't want the square root in the bottom, but if I take the reciprocal of that, the reciprocal is going to be 2 square roots of 7 over 4, because I put this on top, this on bottom. Again, that reduces to the square root of 7 over 2. That's its reciprocal. So I come over here, and I'm just going to do, remember, the square root of 7 over 2 is the reciprocal. Square root of 7 over 2. Now all I did was I did the reciprocal. They might not look like the reciprocal, but they are the reciprocal. If you don't believe me, what we can do is we can take that 2 square roots of 7 over 7, right? 2 square roots of 7 over 7. Its reciprocal would be 7 over 2 square roots of 7, times that by the square root of 7 over the square root of 7. Again, I'm rationalizing the denominator. That's going to be 7 square roots of 7 over 2 times 7. But the 7's cancel, and I get the square root of 7 over 2, which is what I had, square root of 7 over 2. So the cosine is of D is the adjacent over the hypotenuse. So it's going to be the 2 square roots of 3 over 2 square roots of 7. 2 square roots of 3 over 2 square roots of 7, because it's adjacent over hypotenuse. 2 square roots of 3 over 2 square roots of 7. The 2's cancel. I'm going to multiply by the square root of 7 over the square root of 7 to rationalize that denominator. I'm going to get the square root of 21 over 7. That's my cosine. So on here, I'm just going to come in here and insert my fraction, and I'm going to type in the square root of 21 over 7. Again, when you're working in your iExcel, this is kind of the way you do it, over 7. Now I'm going to do the reciprocal of that. But when I do the reciprocal, I'm going to come back here, and I'm just going to do the reciprocal of my original square root of 3 over square root of 7. Remember, so I'm going to take the reciprocal of that, which is the square root of 7 over the square root of 3. Because remember, the reciprocal of cosine is adjacent over hypotenuse. The secant is hypotenuse over adjacent, so it's going to be 2 square roots of 7 over 2 square roots of 3, right? 2 square roots of 7 over 2 square roots of 3. 2's cancel, and I'm left with the square root of 7 over square root of 3, or just taking the reciprocal of the cosine. Again, rationalize my denominator, and I get the square root of 21 over 3. So I come back over here, type in my fraction, square root of 21 over 3. Last but not least is the tangent. Tangent is opposite over adjacent, so it's 4 over 2 square roots of 3, right? Opposite is this side, adjacent's this side, so it's 4 over 2 square roots of 3, 4 over 2 square roots of 3, 2 goes into 4 twice, so I'm left with 2 over the square root of 3. Let's rationalize that denominator, timesing by the square root of 3 over the square root of 3. We get 2 square roots of 3 over 3. So I come back over here, and I type in here that fraction, of 2 square roots of 3 over 3. And now what's nice is the cotangent is just the reciprocal of that. And it's already reduced. It's going to be 3 over 2 square root of 3. Oh, well, actually, that's not a rationalized denominator. Let's go. I don't know why I did that. Let's go back to the original, or in other words, just remember that the cotangent isn't opposite over adjacent. It's adjacent over opposite. Adjacent is 2 square roots of 3. That's this side here. Opposite is 4. So I get 2 square roots of 3 over 4. 2 goes into 4 twice. And so it's just the square root of 3 over 2. Square root of 3 over 2. So if I was to rationalize this denominator, I'm going to get the square root of 3. So I'm going to come back up here, put this underneath the square root of 3, or underneath the square root of 3. And then I'm just going to get rid of this and make it square root of 3 over 2, which is the reciprocal of this. So just be careful when you're rationalizing the denominators. If you do have any questions, please contact me, and I will help you in any way I can.